Hello again, everyone, and thank you for such a great opportunity to talk to you. Uh, Definitely, every one of you knows that Angular is heavily used in RxJS. So question of unit testing for observables are quite important for everyone. And in this talk, I will review all the tools that can help you to do that. And you can choose which tool fits best for your code. So let's go. Oh. Yes. Uh, as Robert said, my name is Oleksandr Poshtaruk. I'm senior front-end developer, working 4+ years in commercial projects, mostly in the NDA, of course, that I use in Angular and RxJS. I'm Angular and RxJS mentor on codementor.io portal, writer for Angular in-depth blog, and video courses author on RxJS, like hands-on RxJS for web development and RxJS Unit Testing in Angular. Also tried to do a YouTube series. It contains about 8 videos as of now. Angular can waste your time. You can take a look if you want. Sorry. Married, father of 2 playful sons, and quite happy with them. If you already tried to code unit test for observables, then you may be a bit overwhelmed with a variety of methods how to do that. At least I was. So which method is right for you, and what is common for them, and where they differ, and how to put all of these methods in one solid picture in the head? Yes. So this is what I'm going to bring you in this talk. I will make you understand the system of methods. These are code examples I will be discussing tests for in this talk. So let's review them real quick. These are RxJS code. First one is autocomplete suggestions example. Yes, you type text in input element and we transform this text change to stream. And after the bounce time, this text is sent to the backend. And backend will send you back a list of suggestions to show to the user. So notice that we use the bounce time operator here. So sending to the backend will happen after some amount of time, not at once. Second example is real simple for learning purposes. It is a merge of 2 observables into result observable. And third example is using repeat when operator to make repetitive same network requests after specified delay. Delay operator is used for that also. Before we start diving into unit testing, we should clarify what are schedulers in RxJS. You know that observables produce values over time. And the moment when exactly value will be emitted is controlled by special entity, a scheduler. Knowing how schedulers work are extremely important in understanding how to unit test your async code. Okay, now to understand how schedulers work, we have to recall what is JavaScript event loop in a browser. The main entities on this picture are macro task, micro task, and event loop macro tasks queue. Let's take a look at executed code to the left. We have 3 console logs calls here, and first is unwrap, a simple console log. Second is wrapped in set timeout, and third is called in the promise resolve callback. As you see in the browser console, first unwrapped console log is executed. On the second place, we have console log from promise callback, and then on the third place, we have console log from set timeout. Why? It is simple. First console log is executed in the current active macro task. Console log from set timeout will be run in the next macro task, so browser put it in a queue. But promise callback is scheduled to be run in micro task, just after current active macro task. So console log 3 runs before console log 2. That's why output order is 1, 3, and 2. Now RxJS code. This code works the same way as the code on the previous slide. I use RxJS of function to emit values here. And in some cases, I provide second optional scheduler param to the of function. First value is emitted synchronously. Second value is scheduled in event loop macro tasks queue. And third one will be emitted at micro task just after current macro task. Providing schedulers to RxJS of function actually does the trick. The code, I repeat, the code works the same way as it was on the previous slide. Let's take a look at official definition from RxJS GitHub repo. A scheduler is a data structure that controls when emissions are delivered. It means that we can emit data synchronously if we don't use scheduler or use queue scheduler. Or we can schedule emission in micro task just after current macro task if to use async scheduler. And when we use async scheduler, data will be emitted in other macro task at once or with some specified delay. The main challenges we meet during unit testing of observables are data are emitted asynchronously, more than one value may be emitted, order of values may matter, values are emitted with specified delay, and sometimes in prod cases this delay can be quite big. So how to test this code? Translating these challenges to browser event loop terminology, we may say that we should be ready to write unit tests for such cases. For synchronous code, but testing sync code is relatively easy. We will not review it here. For async code that emits in next micro task, like promises do, so we should somehow test it. For async code that emits in next macro task, which is placed in event loop queue, possibly with some delay, and combination of observables, which are frequently used in Angular code. So how to test them? There are two more special schedulers in RxJS just for testing purposes. Virtual time scheduler allows to execute all delayed scheduled emissions tasks instantly, keeping the emission order. So if you are using some operators like delay, debounce time, which waits for some time before emitting value, the virtual time scheduler will help you to pass this time instantly. TestScheduler is a subclass of virtual time scheduler, but with additional methods for unit testing. We will talk about them more deep in this talk. One more thing I wanted to pay your attention to. RxJS provides scheduler classes, but also you can get existing instances of scheduler classes, which are used by RxJS. Getting these instances will help us to change scheduler behavior for testing purposes. The rule of thumb here is if it is a class, its name starts with capital letter. If it is an instance, then its name starts with the small letter. So examples of the imports you can see on the screen. To find out more on topic of browser event loop or RxJS schedulers, take a look at these videos by Philip Roberts and Michael Hladky. They are quite good. But we will not stop on that anymore here, and we will go further. So that's it about schedulers. Now let's start reviewing testing methods for observables. You know RxJS of function. Yes, it creates observable that emits value or values. Here in this example, RxJS of function works synchronously, just like a loop, emitting all the values in the same event loop macro task. So once we subscribe to it, all the values will be produced, and we can easily check them in assertion expression. But things become harder if we need to test async code. Take a look at this example. I changed a bit getRange function, so now all the values will be emitted in different macro tasks. And if we run the test below, it will fail. Why? Because at the time we call jasmine-expect function, not all the values are emitted. They are still scheduled in event loop queue. So sync testing is not applicable here. Can we somehow test async code? Yes, and now we have plenty of tools for that. We will review them. Jasmine framework provides a special done callback to test async code. How to apply it to observables? When specific test is executed, Jasmine holds and waits until done callback is called. So if data is provided asynchronously, we subscribe to Observable, run assertion after we got all the data, and then run done callback to say Jasmine that we can continue running other tests. So let's take a look at the code. If we use done param in test in Jasmine, here we use done param in test in Jasmine. Pay attention, I mark it with the green line. And in that case, Jasmine holds and waits until done callback is called. So we call our function getRange and subscribe to returned observable. In the next handler function, we just add each emitted value to result array. Yes, very easy. And in complete handler, we check the final set of values and call Jasmine done callback afterwards. Success. One more example. Here we make HTTP call with HTTP GET, and if it succeeds, it will repeat HTTP calls 2 more times after specified timeout. This is how repeat when plus delay works. So obviously, async scheduler is used by RxJS delay operator. To test this code, I provide a mock for HTTP GET that just returns 42. Quite famous meaning of life, yes. And then we call getData function with a very small timing, not to wait too long. Yes, so we make delay wait too little time. We push values to result array in onNext handler, and in complete handler, we check final result. And here, the drawback of Jasmine done callback method is becoming obvious. Yes, we cannot test code that had some big delay times. So I provided a very small timeout when I call getData. Since otherwise test run will take too long. But how to omit it? And we will see how. Let's review pros and cons. Jasmine with done callback has such benefits. Yes, it is very simple, and it is good for single values, but as we saw, some range of values can be tested also if we add them to array. But drawbacks is that it is not visual. We can test only final result, and we have to provide very small delays for testing, not to block Jasmine test running for too long. But you may ask, how to test code that uses big time delays? And what if these delays are hard-coded in the code, for example? And this is where Virtual Time Scheduler can help us. Virtual Time Scheduler allows to flush all scheduled emissions instantly, keeping the emission order. So we can use it for RxJS code with big emission delays. You can see that Virtual Time Scheduler inherits from async scheduler. We can replace async scheduler instance with Virtual Time Scheduler instance in our tests. In RxJS, if we want to emit values with some specified delays, async scheduler is used. Async scheduler uses set interval internally to schedule value emissions. For testing such code, we need to make somehow run schedule tasks instantly, but with keeping order of values, not to wait this specified delay. Virtual Time Scheduler can do that. If we replace async scheduler with Virtual Time Scheduler in our function, we can achieve that result. Here are the steps for writing unit test with Virtual Time Scheduler. We feed Virtual Time Scheduler to our code instead of async scheduler. Then we get observable and subscribe to it. And after that, we call Virtual Time Scheduler instance flush method and check the final result. Here's the example. In code here, repeat when will rerun source observable 2 times except first run. Pay attention that I added one more argument to the code, a scheduler, to be able to feed in a virtual time scheduler instance. If we test it with jasmine-callback method, it will take 2 seconds until test is over. It is too long. But if we use virtual time scheduler to get data function, we may get result instantly. And in that case, test will pass and quite quickly. But pay attention that before calling expect, I call scheduler.flush to run all the emissions instantly. Let's sum up. Virtual time scheduler method has such pros. We can provide real production delay values, and we can test even hard-coded values, since time spans will pass instantly. But this method has such imperfections. It allows to test only final result, and additional method param is needed, so we violate code test segregation. Now I want to share a unit testing trick with you. Using extra method argument to provide scheduler instance is not convenient. Yes, it violates code test segregation, as I said, since we have to add something in working code just for testing purposes. To avoid this, RxJS version 6 provides special .delegate property in scheduler class. So if I know that my code uses async scheduler, and I want to make RxJS to use another scheduler instance instead, then I just have to assign async scheduler.delegate property with a virtual time scheduler instance. Let's take a look on an example. To the left, you can see our old code that feed scheduler to the function. To the right, we reassign async scheduler delegate method, and now we can call our function without that additional argument. Yes, test is a bit longer, but there is nothing test specific in our working code now. So this is a trick that can help you to keep segregation, business code and testing code. Angular also has another possible way of testing observables that use async scheduler or emitting data with some delays. For that method, fakeAsync helper function is used. To understand how this method differs from testing with virtual time scheduler, let's take a look on the slide. You already know that we can flush events, emission events with virtual time scheduler. But there is one more way. Virtual time scheduler flushes on a scheduler level, but fakeAsync can flush on a set interval level. So Angular has a specific test helper, fakeAsync, which mocks set interval in the browser. And when we call a special function named tick, mocked set interval execute all the scheduled tasks instantly. So we might not wait actual time. But I repeat, if we use virtual time scheduler, we flush all the emissions on a scheduler level. If we use fakeAsync, we flush it on a set interval level, on more deep level. But actual result is the same. How does fakeAsync work? It uses fakeAsync test zone spec zone instead of standard ng zone. And in that zone, standard browser API like set interval, set timeout, and promise are patched. When we call tick, tasks from internal queue is executed instantly. Okay, here is our example. And here we call getData function without specific scheduler also. And we provide quite big delay value. So repeat calls will be scheduled to be done in 30 seconds. This means that in usual time, we would wait for 60 seconds until observable completes. But with tick function, we can run them instantly. Test passed. But pay attention that we all the test is wrapped with fakeAsync function, helper function call. It is underlined with the red. fakeAsync has the same pros and cons as virtual time scheduler. So we can provide real production delay values. We can test even hard-coded delay values. Test becomes a little bit smaller, and the benefit also, you shouldn't know all the RxJS internals to use it, like schedulers and stuff. And imperfection, it allows to test only final result. So you cannot test some intermediate values or some a few values and how they are emitted and when. Before we start getting deeper in test scheduler usage, we have to understand how test scheduler differs from virtual time scheduler. Test scheduler inherits from virtual time scheduler. As I told you, it has some additional methods for creating unit tests. But let's understand first the difference between virtual time scheduler and test scheduler. So since test scheduler inherits from virtual time scheduler, you may guess that we can use test scheduler in the same way as virtual time scheduler. And actually, it is the right thought. We can take our test with virtual time scheduler and replace its instance with test scheduler instance. But there are some small things you have to know before doing this. Test scheduler and virtual time scheduler has a special max frames param. It determines a time depth for executing scheduled tasks when we flush them. Test scheduler max frame value is set to 750 milliseconds. This is done as sanity checks for marble testing. We will talk about marble testing later. So if your code delays are bigger than that value, you should reassign it. Test scheduler also demands assertion expression when you want to create an instance. It makes test scheduler testing framework agnostic, which is cool. For this example, we will review how to use test scheduler instead of virtual time scheduler. Pay attention that if we call getData with 30 seconds argument, it will take 60 seconds to complete result observable. Okay, let's compare same test code with virtual time scheduler and test scheduler instance. We create instance, providing quite big delay value. Providing mocks. I forgot about mocks for service.http. Then we call our function and provide big delay values. Yes. Yes, correct. And subscribe to result observable. We call flush method to make the virtual time pass quickly. Virtual time scheduler test will pass, but test scheduler code will fail. Why? Remember I told you about max frame value. Actually, it is the value in milliseconds to process scheduled task with delays not more than this time. To fix our tests, we should reassign this param. Here it is. Now all tests are passed. Using test scheduler, just like a virtual time scheduler, has the same imperfection. It is not visual if we have more than one value emitted, and we can check only final result. But test scheduler is capable to solve this as well if we use it in a bit different way. Another testing method, which is more visual and allows to write tests in more obvious way, is marble testing. In that method, all observable sequences are represented as marble diagrams. Marble diagram is a domain-specific language for RxJS to help you visually represent values emitted over time in your test. Here we can see such a diagram for repeat when operator, which is used in our code on the slide. It looks informative and clear. And RxJS Test Scheduler has a special methods that give us possibility to create tests with marble diagrams. Even more, Test Scheduler supports two ways to run such tests. Let's go deeper. Here's our code again. Imagine how marble diagram for this example may look like. We emit first value, it is A, yes. Then we have some delay. After that, a second value is emitted, delay, third value, and completion. As you may guess, one symbol in a diagram represents one time frame. Each frame here equals 10 milliseconds. Parenthesis here tells us that value emission and completion event happens in the same frame. One more detail to pay attention to. Remember the scheduler max frames limit? Now you can understand what is it about. It's like saying, hey, think twice. 750 milliseconds marble is too long if frame is only 10 milliseconds. You may think that here max frame represents number of frames, but no, it is used as a number of milliseconds. Let's review marble testing with Test Scheduler with our first example. It's being done in 4 simple steps. First, we create a scheduler instance and assign to async scheduler delegate. Second, we provide mocks created with special test scheduler function. We set assertion expression with actual and expected observable, and call test scheduler flush method. Let's take a look at some parts of the test to understand it better. In our code, we create mock for HTTP service call that returns observable. And for marble testing, we use special function, create called observable for that. As a first param, we feed marble diagram. In our case, we just emit A and complete observable. But what is A here? The exact value for A will be taken from mapping object, which is sent as a second param, marble values. Marbles has special assertion expression, expect observable to be. Expect observable accepts one param. It is observable that we want to test. And to be method waits for marble diagram of expected output result and respective mapping object with the actual emitted values. Pay attention that we have to provide a small delay value here. Why? Because default frame length is just 10 milliseconds. Can we increase it? Yes, but since each symbol in a marble diagram represents one frame, this means that emission event of A value will take bigger time on the diagram as well, which is impossible in a production. So still same imperfection, small delay values. Marble strings has a special syntax, and here is the list of possible symbols you can use. The mostly used ones are dash, which simulates the passage of time that equals one frame. Letters from A to Z can represent mapped values that should be emitted. And pipe shows when emission is complete. I will not stop more on these symbols. You can read more about them by the provided link. Here you can see some of the test scheduler methods which are used for marble unit testing. There are more of them, but these are ones you will be using most of the time. If you want to dig deeper, just check the link I provided here. It is a special marble testing guide from RxJS team. Okay, let's review example where we combine two streams. Actually, combination of streams is where marble testing really shines. Pay attention to mock observable marble diagram. When diagram is visual, it is easy to create expected output diagram. Test passed. Let's wrap up. This testing method has such benefits. It is visual. We can make a visual test where all emitted values are checked. And since we reassign async scheduler delegate property, there is no need for additional scheduler param in tested code. And it has drawbacks. Delay values are not production ones. This is because default marble frame length is 10 milliseconds only. We can increase marble frame length, but it is not convenient and doesn't allow to emulate exact production behavior. Now we will review jasmine-marbles library. Jasmine-marbles is just a REPL library for RxJS test scheduler to reduce code boilerplate. So it provides the same functionality which we had just reviewed, but makes tests shorter. You remember our test scheduler example. Now let's transform it to use jasmine-marbles. To understand how jasmine-marbles can reduce code boilerplate, let's compare tests done with test scheduler and with jasmine-marbles. In examples with jasmine-marbles, we should not create test scheduler instance by ourselves. Library does it implicitly. But we still can get test scheduler instance with getTestScheduler helper function. Also, TestScheduler provides shorter helper function names. Compare create called observable from TestScheduler versus called function from jasmine-marbles. And flush method is called implicitly by jasmine-marbles as well. Here is comparison table of how helper methods are named in TestScheduler and in jasmine-marbles library. They're actually the same methods under the hood, since jasmine-marbles just wraps original TestScheduler methods. You already noticed that jasmine-marbles call TestScheduler flush implicitly. How it is implemented? Here is a part of jasmine-marbles source code. It just defines additional after each handler for that and calls flush method. So we should not call it by ourselves. Okay, pros and cons. Jasmine-marbles has the same benefits and drawbacks as TestScheduler since it's just a wrapper library, but it allows us to reduce a bit our test code. And Angular official documentation actually uses jasmine-marbles sometimes for test examples. One more thing. What if in our marble test, we could provide more exact delay values? Like this. This notation is called time progressive syntax, and it is much more convenient. So, as I said, jasmine-marbles has this small timing limitation drawback. But starting from RxJS version 6, new run method was added to TestScheduler, which allows to use time progressive syntax in marble diagrams. So we can specify explicitly delay values in convenient manners. Remember our example, it would be so great to provide such clear timing values in our marble diagram string. And in RxJS 6, as I already told you, we can do that. Let's review the example. So test is created in 3 steps. First, we create TestScheduler instance and provide assertion expression. Second, we call TestScheduler.run method and provide callback function with our test code inside. Third step, inside provided callback, we call our assertion expression with expected observable helper function. All the helpers are provided to our callback by TestScheduler.run method. You may ask, what is the difference between the old TestScheduler way of testing and new TestScheduler.run method? Here is a small comparison of differences we have for these 2 methods of testing. The most noticeable distinctions are frame duration is just 1 milliseconds, unlike 10 milliseconds in old TestScheduler way of testing. Flush method is called implicitly. Async scheduler delegate trick is applied implicitly as well, so we don't have to add scheduler argument to our function and don't have to assign TestScheduler delegate with TestScheduler instance manually. And of course, time progressive syntax, super convenient way of specifying delays in marble diagrams. This is the blueprint of tests when we use TestScheduler.run method. Providing assertion expression to TestScheduler allows us to use it with any testing framework, not only with Jasmine, but Jest, Mocha, and any other. Pay attention also to helper functions. They are provided now with shorter names, very similar to jasmine-marbles helpers. Okay, let's run our tests. So, how do you think? Will it pass? But it failed. Why? Because there is one small nuance when we calculate exact values for delays between data emissions when we use marble diagrams. And Kevin kindly provided his tweet where this nuance is very well explained. You have to subtract 1 millisecond for the previous value alphabetic sign and also for the brackets. So expected marble diagram for our example will be a bit different, like you see on the slide. Now, if you try to run the test again, it will pass. You may think, hey, it's so tricky to calculate exact delay values for marble diagrams, but there is a possibility to make it easier. Remember we provided assertion expression for TestScheduler constructor. This assertion function has two params, expected value, calculated from expected marble diagram, and actual value, which is generated by code on the test. If to console log these arguments, we can compare timings of expected and actual emissions. And with this information, it will be easier to understand what is going wrong. Let's review how TestScheduler.run is implemented under the hood. Here is a shot of TestScheduler source code. You can see that max frames is set to infinity. We remove any time limitations for marble testing, since we have time progressive syntax already. Async scheduler delegate trick is applied implicitly as well. And flush method is called in implicit way as well. Time to sum up. TestScheduler.run has many benefits. All tests are visual, and we can check every single value. Prod timings can be provided using progressive syntax. Async scheduler delegate trick is applied implicitly, and flush method is called in implicit way as well. And it is not tied to any particular testing framework because we provide assertion expression when we create a scheduler instance. Among drawbacks, nuances with timings calculations, and some big learning curve. But hope after this talk, this will not be the problem for you. TestScheduler.run method is perfect, but even for this solution, there are wrapping libraries that allows to improve developer experience. There is a REPL library named rxjs-marles. You may wonder, why one more REPL library for TestScheduler since we already have jasmine-marbles? As for the moment when I created the talk, the main imperfection of jasmine-marbles was that it doesn't support new TestScheduler.run method, so we cannot use time progressive syntax. While RxJS-marbles supports both testing methods with TestScheduler flush and TestScheduler.run methods, and supports time progressive syntax. To be 100% sure, I even checked their sources. And as you can see, RxJS-marbles uses TestScheduler.run method under the hood, and jasmine-marbles wraps all TestScheduler way of testing. There are even more benefits that RxJS-marbles provides comparing to jasmine-marbles. It is testing framework agnostic. It also provides many examples in its GitHub repo and have a few neat helpers like cases and observe functions. We will take a look at them. Here our first example with RxJS-marbles sleep. We use marbles helper function here. As you may say, hey, it looks very similar to test with the TestScheduler.run method, and you are right. Marbles helper just wraps the TestScheduler.run and creates the TestScheduler instance under the hood. All the other test code is the same we used for the TestScheduler.run method. But test now looks a bit shorter. Depending on the import path which you use for helpers, rxjs-marbles will instantiate TestScheduler and provide assertion function from respective testing framework. Also, there are many test examples for each framework as well in the GitHub repo. You can take a look at them by link on the slide. There is also an interesting helper function called cases. If you want to run same test but with a few different input params, then cases helper is what you may need for that. Pay attention that it replaces jasmine-it function totally. So we don't write it, but write cases. Sorry, 1 second. And one more helper function, observe. It works in the same way as jasmine-done callback, which was the first method we reviewed. Actually, it is a wrapper for it. Observe accepts callback that should return tested observable. An assertion expression should be provided as a side effect with rxjs tab operator. Like jasmine-done method, it works only with final result after observable completes. In a chat with rxjs-marbles creator Nicholas, he told me that he started the library before even TestScheduler.run method was implemented in RxJS 6. And as for today, it is far less necessary to use it. So just use TestScheduler.run. But as you saw, it allows you to reduce a boilerplate code anyway. So to sum up, rxjs-marbles provides the same benefits as TestScheduler.run method, time progressive syntax, implicit calls of flush, and async scheduler delegate assignment. And among drawbacks, you must spend some time to learn it. Also, it has same timings calculation nuance as we already reviewed for marble diagrams. There is one more TestScheduler REPL library, Rx Sandbox. I will not review it here, but just wanted to mention. You may want to take a look to learn something new from it. To continue learning Observables unit testing, you can use these links. Take a look at official RxJS manual as well as marble examples in RxJS GitHub repo. Also, jasmine-marbles and rxjs-marbles is another good way to write unit tests with less code. I want to say a special thanks to Nicholas from RxJS team, who helped me a lot in understanding RxJS source code. Also, thanks to Kevin for allowing to use his neat tweet about marbles timings nuance. And I'm grateful to Angular and Dev community that inspires me a lot, and there are people always ready to help. This talk is a shorter version of my video course on Udemy, free video course on Udemy, RxJS Unit Testing in Angular applications. So enroll and learn more. So thank you for your patience and hope this talk brought something useful for you. It was quite quick, but you can find always more information in my free video course. Also check my articles on Medium and Dev2 platforms. And thank you once more, and now questions time.